Hi, I'm Dean Bushmiller with Expanding Security, and this is Encryption Tools and Techniques. Use or consumption of this material by AI is expressly forbidden. Let's get started. When we look at encryption tools and techniques, we want to zoom out to cryptography for just a second here. There are 13 topics in the cryptology framework that's out there. We're on this last one right here, encryption tools and techniques. And the order of these things really doesn't matter. I think that you should do the principles and practices up at the top, but these are all the different cryptographic elements that you should be familiar with if you want to have a full experience with cryptography. So this is what we're focusing in on right now, which is really about the practical application and operational life cycle of securing data, the things we do on a day-to-day basis. If you drill down into that, you'll see that there are kind of 5 topics, well, 5 examples that we're going to talk about today, which most people are interested in doing deployments on. We're not going to do the actual deployments, but we're going to talk about all of the components in them, including a little bit of demonstration on how these things work. And the first one is FIDO, which is the thing that I just showed you right here. We're also going to talk about full disk encryption, file level encryption, secure shell, and we're going to talk a little bit about transport layer security. There's a whole section on VPNs, but this section I'm going to talk about TLS VPNs rather than IPsec VPNs, and we'll leave that for the VPN section. You should check out that video there. I want to say to you, what I've learned over the past couple of years is deployment is easy. Okay, well, deployment is easier than it was 5 years ago. Deployment is easier than it was 10 or 15 years ago. It was hard to deploy encryption and most people didn't want to do it. And because there was such pushback on this, well, nobody implemented encryption until they were actually demanded to by some sort of compliance that was out there. Maintenance is difficult. And the reason is that nobody wants to change when it's working. It's like, we just got this thing set up. Can we not screw around with this? It's working. It was hard to get it working. Let's not screw with it. So you don't get upgrades as often as you would like to. The most difficult thing I find in all of this is long-term key management. It sucks to be us, especially with DNSSEC, where we have to update keys and talk with the PKI people very, very frequently. This is not an easy task. The AI in cryptography is a little bit different. You're not going to see it at the deployment level, but it is coming. Okay. Here's the thing is AI works without getting tired. It's a machine. There is a low cost, long-term effort about testing encryption due to statistical failures and things like that. And I'm going to show you a couple of examples of that. That takes a long time, and that statistical analysis by a very expensive mathematician, a cryptographer, or cryptanalyst, we can automate a lot of that today. One of the things that we also have to do when we're building encryption or using encryption is we have to understand that it is a pure reasoning problem, especially for the design of encryption. And the great thing is that those costs, once the cryptographers get things set up and in motion, they can get the cryptography machines the AI machines to take care of it for them. What's that look like? Well, let's start with agentic cryptanalysis evolution. What's happened lately? Well, we can perform differential cryptanalysis on many, many, many samples, thousands, hundreds of thousands, even millions of samples to prove that it's actually working. We can figure out that there are statistical bias that we should not be having in cryptography when we're building new cryptography and go, there's a statistical bias, because we can run through all those calculations that would normally take, a cryptanalyst years to do. We can even execute side channel attacks in a variety of different ways where we can test the timing and also the power differentials that we otherwise wouldn't be able to do for all the different experiments, if you will. So that experimentation where we'd have to capture those scientific results, like 100,000 of those results, becomes a parallelization problem, a math problem that we can kind of walk away from at this point, only to return for the results and let the mathematician look at it and go, these results are true, these results are not true, but I didn't have to work through the math on every single thing. The other piece to this is in implementation, because that's what we're talking about in this section. In implementation of tools and techniques, there are going to be software vulnerability profiles that will crop up in encryption. Like, we might want to look at the vulnerable algorithms that are available with a particular set of protocols. Maybe we don't want to implement TLS 1.2, we want to only implement TLS 1.3, but when we go to look at those protocols from an agentic standpoint, we can say, oh, there's the ability to have these other protocols in here. We want to disable that completely, or we want to turn on security mechanisms where we can detect that. There's also things like poison model weights where we can actually poison those. That's a statistical analysis. Executing inference attacks, analyzing the encrypted metadata, again, really, really painful for us to do as individuals. Hand it over to agentic and it can handle it for us and go through all the permutations there. And the other one that's really cool that I've seen a couple of times is to trigger hidden backdoors. So I find this just absolutely a great way to look at AI helping us with our encryption tools and techniques. So I hope you'll join me for the entire presentation.